Last lecture we have developed for finding out area of parallelogram. Let us write down. Today's first thing that we are doing is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 are the two lines, right? Equations of angle bisectors. And we know that angle bisectors are a1x plus b1y plus c1 divided by radical a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 divided by radical a2 square plus square. Okay, so there are two. If there are two lines, there are two angle bisectors. And angle, we know by geometry, these two angle bisectors are going to be perpendicular to each other. If we find out slopes of these two lines, m1, m2 is bound to be -1 in this case also. Now we will have to work a little hard and say what are the things that we have in hand, because we will be given two equations. They will look like this. You will come to know these 6 parameters: 1, 2, 3, 4, 5, and 6. These are the 6 things which you will be given, and which questions will you ask? Will be asked. Question 1: is origin in acute quadrant? Okay, if these two lines are perpendicular, that is the easy situation. We come to know very quickly that they are perpendicular. So let us assume that we are not dealing with easy situation, we are dealing with difficult situation when these two lines are not perpendicular. Therefore, one angle will be acute, another angle will be obtuse. So question number 1, whether origin lies in acute quadrant, is origin in acute quadrant. Maybe question 2, which amongst the two? Bisectors pass through quadrant containing origin. Similarly, I can ask which amongst the two bisectors pass through acute quadrant. Okay, and maybe the third general question which can be asked is which bisector passes through quadrant containing, say, x naught comma y naught given to you, and you are supposed to identify. Suppose x naught comma y naught is lying here in this diagram, x naught comma y naught. Then we are supposed to report answer for b1 and not for b2. This is bisector 1, bisector 2. Okay. So what we will do is we will simultaneously develop theory and let us have one numerical also along with us side by side, so that we come to know doing is becoming true or not for that human numerical, and in general then we will develop a formula. Okay, I have to ask you whether we have done this in 10th, 9th or not. Okay, so while deriving the formula for answering these three questions, simultaneously we will solve one problem. So this is the problem. Line number 1 is 7x minus 6y is equal to 8. Line number 2 is x plus 8y is equal to 10. Find answers for question 1. That means, is origin in acute quadrant above these two lines? Which amongst the two bisector pass through quadrant containing origin? It is acute quadrant. I mean, question 2 is containing origin. Question 3 is which particular bisector passes through acute quadrant? And question 4 is which bisector passes through quadrant containing 5, minus 2? Chalo, let us see what procedure you adopt. Correction, second line, 9x plus 2y is equal to 20. Then the numbers of bisectors will be good, coefficients will be good. So solve this problem using these two lines. So let me get the bisectors in place and then we will work on this. I mean, I will give you sufficient time. So bisectors are 7x minus 6y minus 8 upon root 85 is equal to plus minus 9x plus 2y minus 20 upon root 85. So if I assume plus and take all of them to this side, then bisector number 1 is 2x plus 8y minus 20 plus 8, which is minus 12, is equal to 0, which can be reduced to x plus 4y minus 6 is equal to 0. 2 आणि 4 6 बरोबर. Second bisector will be, if I take minus sign, so I will take everything this side. So now this 7 16x plus 2 minus 6 minus 4y minus 20 minus 8 minus 28 is equal to 0. That is 4 चौक 16 चौक 28. 4 में भाग जाता है 4x minus y plus 7 4 8 हो जाए 0. They are perpendicular. So b1 is x plus 4y minus 6, b2 is 4x minus y, 4x minus y minus 7. Okay, we will come back to this numerical problem little later. Let us draw something and see if we can derive theory for this. Line number 1, line number 2, and maybe origin. Let us call this line as line number 1, a1x plus b1y plus c1 is equal to 0. And let us call this line as a2x plus b2y plus c2 is equal to 0. Right? Now, basically, what we are trying to do as far as answering the first question is concerned, we would like to find out origin is in which quadrant. Okay. Now, when these two lines intersect, सगळ्यांनी नीट लक्ष द्या, कारण आता हे परत परत शिकवलं जाणार नाहीये. एक आणि दुसरं म्हणजे या गोष्टी सगळ्या लक्षात ठेवून पुढे जायचे आपल्याला. So when we have two intersecting lines and if they are not perpendicular, in which case it is very easy situation. We know the four quadrants are formed, and depending upon the equation that we have, these two equations that we already know that vertically opposite quadrants, if suppose this quadrant is plus minus, I mean line number 1, this is L1, with respect to L1 it is plus, with respect to L2 it is minus quadrant, then vertically opposite quadrant will be minus plus. This discussion we have done in 9th standard. If this quadrant with respect to L1 is positive and with respect to L2 is also positive, then automatically the vertically opposite quadrant is going to be negative. Now we are not going to denote them permanently because they depend on these equations. Numerically, suppose first equation of A1, what was our first equation of A1? A1 was 7x minus 6y is equal to 8. Suppose it is 7x minus 6y is equal to 8. Then the moment I multiply it with minus 1, all the quadrants as far as first one is concerned, everywhere it will change. First this positive will become negative, this positive will become negative, this negative will become positive, this negative will become positive. So if I multiply any one of the two lines by minus 1, then the quadrants, whatever we are trying to name, are going to change because it is altogether a different equation of the same line. Earlier, if origin was in minus minus quadrant, if I multiply L1 by minus 1, it will end up being in plus minus quadrant, right? But as far as bisectors are concerned, bisector will either pass through plus plus minus minus quadrant, or it will pass through plus minus minus plus quadrant. That is good about bisectors because they go vertically opposite quadrants. And that is why we don't want to name these quadrants permanently. However, to get rid of this ambiguity, what we would like to do is write down these two equations of L1 and L2 just to get rid of ambiguity. Write down both these equations in the form C1 and C2 positive. Right? In the form C1 comma C2 greater than 0. Okay. So in our case, maybe our first equation was 7x minus 6y is equal to 8. We would like to write down L1 or maybe new L1 dash. It is the same line, but equation is written in different way, which is minus 7x plus 6y plus 8 is equal to 0. So you write it in this fashion so that this constant is positive. L2 dash is also going to be written in the same fashion, 9x minus 2y plus 20. Minus 9x minus 2y plus 20 is equal to 0. I mean, this is the algorithm that I am trying to tell you, and why that algorithm works also I will tell you. Finally, in this particular case, when we see these two lines, both RHS are positive. That means both of them have same sign. That means origin is in the quadrant plus plus or minus minus. That you can visually find out very quickly by looking at these two lines. If this constant was positive and this was negative, then origin will lie in opposite parity quadrants. That also by experience you will be able to do it. But if we don't want any mistake to happen, then we will rewrite the equations of L1 and L2 such that the constants C1 and C2 are positive. Now if we substitute 0 in these two equations, you are bound to get plus plus. Origin is in plus plus quadrant. Up to this point, I hope it is very easy. And therefore, if we write down these two equations like this, then what will happen? The bisectors equations B1 will be minus 7x plus 6y plus 8 divided by root 85 is equal to plus or minus 9x minus 2y plus 20 upon root 85. So as a thumb rule, it was said that you select positive sign here if you want to look for bisector passing through quadrant containing origin. That was the statement we made in 9th standard. So the bisector passing through, I mean this bisector will have equation minus 7x plus 6y plus 8 is equal to minus 9x minus 2y plus 20, which is 2x, which is x plus 4y minus 6 is equal to 0. So this is the equation of the bisector which passes through quadrant containing origin. This is what we learned. Now at that time also maybe we have not discussed it in detail. Why should we have plus here and why not minus? Our claim is if we take plus here in RHS, we will get the bisector passing through quadrant containing origin. And if we take minus, then we will get the other. Now, can you help me in knowing the reason behind it? Why? Why plus? I wait for some time. Okay. So, when it comes to distance, measuring distance, till 8th standard, we said distance is always positive and we took it as distance AB as absolute value of B minus A. Whether B is to the left or A is to the left of B, we don't know, but we took it as absolute value. When we call AB is equal to B minus A and BA is A minus B, then AB is equal to opposite of BA. Here what we are talking about is directed distances. Okay. So if we just want the absolute value or what is the distance between Pune and Mumbai, 150 kilometers. You don't know whether you want to go from Pune to Mumbai or Mumbai to Pune. The distance you are asking and it is 150 kilometers. Okay. But if I am facing Mumbai and I want to go to Mumbai, if I am facing B and I want to go to B, then we should consider this as positive 150 kilometers. But if I am facing opposite of B and I want to go to B eventually, then how much is this distance? Minus 150 kilometers. First of all, I have to change my direction and then travel 150 kilometers. Correct? So in case of angle bisector also, what we are doing here is, what is this left hand side? What is this left hand side? Left hand side of a bisector equation is you take any point on the bisector px dash comma y dash and find out its distance from line number 1. So this is our line number 1. This is our line number 1. We are taking origin as our point on bisector. Not really point on bisector, but point in the quadrant through which the bisector is expected to be passing. Okay. And we said if origin is here and line is here, then in numerator when we find out distance in 9th standard we were putting absolute value. But now in the equation of bisector we are not putting this absolute value because we want both the bisectors. There is no point in putting absolute value. Therefore, practically finding out the distance of say origin or of say x which is expected to be on bisector, line number 1. And because we have made this constant C1 positive, if we substitute 0, 0 here, we are going to get positive distance. So let us say that is what we are calculating, distance from here to here, and this direction with respect to line number 1 is positive. That is what we are getting, positive distance. The way I said I am facing B and I want to go to B, then it is positive 150. Exactly similarly, origin if I substitute and I want to go to the line number 1, how much distance should I travel is going to be 8 upon root 85, which is going to be positive. Therefore, this direction is positive. I mean, we have to decide something positive or something negative. So this is positive. Now, what about yes, same story from point on the bisector, because this is equation of bisector. So every point on the bisector will possess exactly same distance from line number 1 and line number 2. So line number 2 is also written in the form where constant is positive. So any point on this bisector, suppose this point if I put on the bisector and check the distance from here, it is in positive direction because origin is in that direction. And with respect to origin, if this distance is also positive, maybe I will put it in different color. With respect to this, suppose this is positive because I am getting a positive quantity here. Not using this, but just using this formula, I am getting 20 upon root 85, which is this distance. I call that as positive to line number 2. And then if I put any point on the bisector, try to find out distance from line number 1, it is in the direction of this, which we assume to be positive, and the other is also going to be positive. Now you see, if I take a point in the other quadrant, then the distance from line number 1 is in opposite direction. Can you see that? It is in opposite direction. Therefore, LHS is going to be negative and RHS is also going to be negative. Because this arrow is also in opposite direction. And therefore, both the sides LHS and RHS should have same sign. And hence we end up putting positive here. That is because you have made these constants positive. Because these two constants are positive, we are saying that the vector from origin towards the line, perpendicular vector, from origin towards the other line, if we assume those directions to be positive, then any point on the bisector number 1 will follow that rule of direction, and every time it will be same. Therefore, it is positive, positive that you should select. If you don't change this, use these equations as it is, then you are not going to be correct. If you are lucky, you will be correct because there are only two bisectors. You will write correct bisector or wrong bisector. But then if you want to write down the answer correct every time, you might as well know the reason. Okay, I don't know whether you have understood this or not. Let us take any point on the other bisector. The other bisector here is say B2. If we take any point on B2, say let me take it here and put the perpendicular on L1, can you see it is exactly in the direction of this. Now these two arrows are our references. These two arrows are our references. This one and this one. Okay. So now from this point on B2, if I drop perpendicular onto L1, I am in the same direction. Therefore, let LHS be as it is. If I go to L2, I am in opposite. Therefore, I must select minus because direction is different. This distance, whatever direction I will get, I need exactly opposite of that. So when you look at directed distances, you come to know why this is positive, positive and negative. Why it should be positive. for origin containing quadrant. If you take any other point on the other side of the bisector B2, you go to line number 2, it is in the direction of the origin distance positive. So RHS is going to have same sign that of this. However, LHS will have opposite sign from here to here. Correct? Therefore, all points on the bisector B1 will be same parity, same parity. All the points on the bisector B2, different parity, different parity. And therefore, the origin containing quadrant, if you want to find out the bisector, first thing, make C1, C2 positive. Second thing, don't worry about negative sign, just write down the equations of the bisectors. Okay, that is one part of the story. Now the important part of the story is this, I have drawn it acute, but is this really acute or is this really obtuse? I don't know. We will find out. Sure. I can keep this on the board 50% so that some of you, if you want to write down. Okay. Now let us look at it again. Maybe I will draw the same picture so that we are not confused. Blue L1, L2, bad, perpendicular. Origin. Okay. Now what we should do is L1 is A1x plus B1y plus C1 is equal to 0. L2 A2x plus B2y plus C2 is equal to 0. Now this is where I will use my normal form. If I want to convert this equation in normal form, I will have to write it like A1 upon radical A1 square plus B1 square times x plus B1 upon radical A1 square plus B1 square times y minus or maybe plus C1 upon radical A1 square plus B1 square is equal to 0. Okay, now let us assume for time being that our C1 and C2 are greater than 0 for the simplicity purpose. Okay, after making them positive C1 and C2, we have written those equations here. Okay, so that will be easy to imagine. So this is what is the normal form, and this is cos alpha x plus sin alpha y plus p is equal to 0, or maybe let us call this as, this is made positive in RHS, so okay, I mean we are not worried about that, whatever, p might be negative. Okay, similarly if we work for second line, we will have A2 upon radical A2 square plus B2 square x plus B2 upon so and so. So this is our polar normal equation of line number 1. Line number 2 will look like, say, cos theta x plus sin theta y plus q is equal to 0, right? So what do we mean by this? We mean that if I drop perpendicular from origin, if I drop perpendicular RH, जड़ झालं तर मायक्रोसॉफ्ट मला बोर्ड बंद झाला की नाही. Wait a minute. Let me pause recording. Okay. So we are using this as normal form. So we draw normals and indicate this alpha angle with respect to L1 and theta angle with L2. Therefore, we note down what do we mean by cos alpha, sin alpha, cos theta. Cos theta is A2 upon radical A2 square plus B2 square. And sin theta is equal to B2 upon radical A2 square plus B2 square. Okay. And now what we will be interested in is, see, cos of alpha minus theta. Understand this. If cos of alpha minus theta, what is alpha minus theta angle here? This angle. Angle between the two normals.